So this is a Thermo 2 mini project making seltzers, and we're going to talk about polar seltzers and how they are being made. And everyone likes the tingly fizzy sensation on the tongue from flavored polar seltzers, and the bubbles happen because of carbonation. Carbonation occurs when carbon dioxide dissolves in water to form a dilute solution of carbonic acid. To make carbon dioxide dissolve in water easily, manufacturers need to increase the pressure in the bottle and keep the product at a low temperature. At these conditions, the water molecules can entrap carbon dioxide molecules better. Since the conditions are far from ideal gas, to calculate the solubility of carbon dioxide in water, Henry's law is preferred over the Raoult's law. And here's a chemical reaction for the carbonation process.
So we can actually calculate the equilibrium constant at 298 degrees Kelvin, or room temperature around 25 degrees Celsius. So at those temperatures, your delta H reaction and delta G of reaction can be found because the delta G of formation and the HI of formation are known values. Additionally, the coefficients of the reaction are known because we have, as Danny mentioned, CO2 plus H2O yields H2CO3. This means that the reactants will have a -1 coefficient and that the H2CO3 will have a +1 coefficient. Therefore, using the formula seen on the screen of the coefficient times the delta H of the HI of formation and the delta G of formation, you get delta H of reaction is -18.7 kilojoules per mole, and delta G of reaction at 298 is 24 kilojoules per mole. So you can calculate K at 298, and you get 6.21 times 10 to the -5th, which makes sense because since the delta G of reaction is positive, that means that this reaction is not favored at these conditions. However, you can also find K at other temperatures, as we've done in class. So using this formula here, you can find the third formula on the slide. You can find the K at any temperature. So for example, if you were to decrease the temperature by 10 degrees Celsius or 10 Kelvin, then you would get a K at 88 of 8.07 times 10 to the -5. So you can see it increases, which Noah can get into now.
So as stated, the reaction is exothermic. The delta H of the reaction is less than 0, so it's going to be releasing heat. And so the reaction is desired to happen at a low temperature and a high pressure, which is another reason why the cans are refrigerated after. And this is because if you increase the temperature, the equilibrium constant will decrease, and then the moles of the carbonic acid, which is the product, will decrease, which is not desired. It goes against what the company is trying to do. And because the sum of the stoichiometric coefficients is negative, a high pressure or increasing pressure will increase the moles of the product, and that is desired. So the companies produce the seltzers at low temperatures and high pressures to maximize the moles of product produced.